In this video, we will discuss the problem word wrap. Previously, this problem has been asked in Flipkart and Microsoft. So the problem says that you will be given an array that will be of n size. So you'll be given an array that will consist of n elements, and the ith elements denotes the length of the ith word, right? And you'll also be given a value k, that is the number of characters that you can have in a particular line. What you have to do is you have to put the words in the lines one by one, and you have to tell that what is the minimum cost. Let's try and understand this problem through a particular example. So let's say if the array that has been given to me is of 4 size and it consists of elements, let's say as 3, 2, 2 and let's say 5, right? So if this particular array has been given to me, right, so that this basically indicates that the first index, that is 3, indicates that there will be a word of length 3. Let's say that if it was GFG, let's say the word 2 of length 2 can be, let's say, Go, that is one of the programming languages. Let's say the word of length 2 again could be, let's say, CP. Another word of, let's say, length 5 could be code, right? So these words can be there, right? Basically, you can associate any words, but basically you will just be given the length of the words in this problem, right? And you will be also given a value of k. The k value is what? Here the k value is 6. It denotes that how many number of characters you can have in a particular line, right? Okay. This is the thing. Now what you have to do in this particular problem is you have to find the minimum cost. Now what does it mean by finding the minimum cost? So let's first associate this. So the word with length 3 let's say is GFG. The second word with length 2 is, let's say, Go. The third word with length 2 is, let's say, CP, right? And let's say the fourth word with length 5 is nothing but, let's say, coder, right? So these are the words that we have. So let's try and understand through the simple example. So let's say you have 6 spaces, right? So you have 6 characters that you can put in a particular line. So let's say you put the first character, that is GFG, right? After that, let's say your ith character is this particular word. Let's say your ith character is this particular word Go. So you have two options. Either you put this particular Go in the same line, or you put it in the next line, right? So let's say if you have this GFG, right? So after that, you will be taking one space, right? You will be taking one space. Only then you can differentiate between the words, right? Only then you'll differentiate. If you write this thing GFG space Go, then you will be able to understand that these two words are different, right? So irrespective of the fact that how many spaces were there, you will use just one space in between so that you can write it, right? That's how usually you do it, right? So either you can choose either you can choose to put this Go in this line, right? Or you can choose to put this particular thing Go in the next line, right? So if you put it in the same line, Go, if you put Go in the same line, in that case what happens basically is, if you put this Go in the same line, so in that case, how many number of remaining spaces are there? Basically this particular remaining space that is there, you have to use it, right, to distinguish between two words, but there's no other remaining space. So that's why you'll say that remaining is equal to 0, and what you have to do is you have to tell that what is the remaining cost. So it is 0, so 0 into 0 will be nothing but 0, right? So the cost is 0, right? But suppose instead of doing this, if I instead of putting this Go in the same line, if I had put it in the next line, which was also containing 7 space for 7 characters, in that case if I put this Go in the next line, in that case I can say that I can say that three characters are basically wasted, right? So in that case 3 remaining characters were there, 3 remaining spaces were there, right? So in that case I can say that the cost will be 3 into 3, that is nothing but 9, right? So this is going to be the thing. Now similarly, let's say my ith character moves to this. Now suppose that instead of Go, my ith character is, let's say, CP, right? So if my ith character is CP, so I have two options. Either I can put CP in the same line, right? Either I can take one space and then I can put CP here, or I can put it in the next line, right? So these kind of scenarios can be there. So what the task for me is to minimize the cost, right? So how can I minimize the cost? Let's try and have see two scenarios. So suppose this is the first scenario that I can do, right? There can be many scenarios, but I'm just thinking about two scenarios. Let's say what I do is I put this word GFG, right? After that, what I do is I take one space and then I put Go, right? After that, let's say I have again 6 spaces in the next line. I have again 6 characters that I can put, right? So after that, what I do is, let's say I put CP, right? So let's say I put CP here. After that, how many spaces do I have? I just have 4 spaces, right? That is nothing but 3 working spaces are there. But I cannot put the coder word here, right? Because I cannot do COD and ER in the next line, right? I have to put a particular word in the same line. So that's why I have to use the next line. And if I use the next line, so what happens? Space is space is space, then space, then space, then space. Like these are the 6 spaces that I have, and the coder word, right? So I'll put this word coder here. Okay. And interestingly, like you will say that for this the cost is 0 because there's no extra space. So 0 into 0 will give me 0, right? So the cost for this a particular thing is 0. Now you'll say that in this how many extra spaces we are taking. You'll say that 1, 2, 3 and 4 spaces we are taking, because you have to consider this particular space as well. So total 4 into 4 will be nothing but 16, right? And you will say that for this the cost will be 1 into 1, that is 1. No, that will not be the case, right? For this, for the last word, you will not have any cost, right? Because if you will see this particular problem statement, so it says that the extra spaces include spaces put at the end of every line except the last one, right? Because if the words are ending, so in that case you will not consider it. Basically you will not consider this space, right? Because you don't require it. So if there are any spaces for the last word, so in that case you will say that the cost will be 0, right? Because you will not consider this part, right? Now how much is the total cost? The total cost is coming out to be 16, right? Let's try and imagine another scenario, right? So let's say if the scenario was like this, right? Let's say I had 6 spaces here, and here also 1, 2, 3, 4, 5, 6, and then here also I add spaces, right? So let's say what I do is I put GFG first of all, right? Let's say I put GFG first of all in the very first line. Let's say I put GFG, right? After that, what I do is let's say in the next line I put go, right? So I assume that I am putting the next line. In the next line I am putting this word go. So what I do is I put go in the next line, right? After that, what I do is I take one space and I then put CP, right? So after this, how many extra space that I am taking, right? So I'm taking this particular extra space, right? You can understand that I'm taking this particular extra space, right? After that, what I do is I put this word, right? I have to put coder in the next line, so I put coder, right? So you can basically see that how many extra lines extra spaces I'm taking. So here 3 extra space, right? That is nothing but 9, right? 3 into 3 will be 9, because this is one extra space, right? This is one extra space, this is one extra space, this is one extra space. That is nothing but 3 into 3. The cost will be 9. In this case, the cost for the last word will be 0, and in this case just one extra space, so 1 into 1 will give me 1. So the overall cost will be 9 plus 1, that is nothing but 10. And you can see that this arrangement will give me the minimum cost, right? So I have to arrange the words in this way, and note that I cannot take the words in any order. I have to take the words in the order. I have to take the words in the order that they have been given in this particular array, right? So this is also one of the scenarios, right? So if you will try to think, right? So if you will try to think, so you maybe initially what you can try to think is you can try to think in terms of greedy format, right? But greedy format will not work, right? Because you have to minimize the cost, and there can be scenarios where your greedy thought process might fail, right? So what you will be doing is you can implement this question first of all using recursive approach, right? So basically what you can have is you can have several scenarios in front of you, right? So suppose let's say that there is a scenario like this. Suppose what you have is GFG, go, CP, right? If you have these words, let's say you have GFG, then you have go, then you have CP, and then what you have is coder, right? If you have these words, and suppose that there are some scenarios, right? Suppose that there is a scenario such that you have like you have this spaces, right? So you have 6 spaces. Let's say you put first of all CP, right? So after that you have 4 spaces, right? But actually there are 3 working spaces that are there, right? Because you have to start filling the next word from here. So if you have this word coder, right? So coder is of word word itself is of length 5, right? And you have just 3 remaining spaces left for you. So can you put this coder in this line? No, you cannot, right? So in that case you have to put it in the next line. You have to put it in the next line derivability, like you have to put this coder in the next line, right? That is something that you have to do, right? Similarly, let's say that if you instead of this, let's say if go was already filled, then you can put CP here, right? You can either choose to put this CP thing here in this line, or you can choose to put it in the next line, right? Either you can choose it to put it in the same line, or you can choose to put it in the next line, right? So basically the thing is that if it happens that, let's suppose that there are some remaining number of spaces left, right? So the number of remaining is left, right? So if my RFI, if the length of the ith word, if it's greater than the number of remaining words, right? If it's greater than the number of remaining positions that are left, in that case I have to put it in the next line, right? Otherwise I always have a choice, right? As I told you, if the current word is coder and I just have 3 spaces left, in that case I have to put it in the next line. I have to pay the cost, right? Otherwise, if that is not the case, so in that case you can definitely say that either I can put it in the same line or I cannot put it, right? So let's try and build the choice diagram for us, right? Let's try and see this. So basically, let's say that you are currently calling a recursive call, right? You are currently having a recursive call for I, comma, what? Let's say remaining number of words, right? This is what you are having. So there can be 2 scenarios, right? There can be 2 scenarios. The scenario can be that if your RFI, right? If your RFI is greater than what? Is greater than the if the length of your current word, if it's greater than the number of remaining spaces that are left for you, right? In that case, you will tell me that I do not have any choice, but like if, as I told you, right, if there were 6 spaces, right, if there were 6 spaces and CP was already filled there, right, if this word CP was already filled, so you cannot fill this word coder here, right? You have to move to the next line, and in that case you have to pay this much cost, right? You have to pay the cost for the remaining words. Now what is the thing? The thing is that what actually you do is you say that, okay, how many remaining words, remaining number of positions were there? The remaining positions were 3, right? You say this thing, but actually are the remaining position 3? If you choose to put the coder word, if you choose to put this coder word in the next line, right? If you choose to put it in the next line, so in that case, are there actually 3 spaces remaining? No, you actually have 4 spaces remaining, right? So in this case, the cost will not be 3 into 3, but the cost will be 4 into 4, right? That is nothing but 16, because there are actually this space is left, this space, and this space. So total 4 spaces are left, right? So that's why in this case you will say that the cost will be nothing but remaining plus 1 into remaining plus 1, right? That will be the cost that you will bear, and you will definitely move to the next line, right? So that is something that you will do, right? So you will say that in this case, what you are going to do is you will say that you will pay a cost, and the cost will be nothing but cost will be equal to remaining plus 1, right? Into remaining plus 1. Why remaining plus 1 into remaining plus 1? Because as I told you, right, you if you have put this CP word, right, so after that, if you have put a current word, so you will not immediately start putting the word from here, right? You will say that this is the position that you can put in, right? So actually not 4 positions were remaining, but 3 positions were remaining. So that's why in the next recursive call you will say that recursively you have only 3 positions left in the current line. Okay, that is the thing. But actually if you are not putting the word, so in that case you can say that remaining into remaining plus 1 into remaining plus 1 number of spaces are left, and that is the cost you have to pay for this particular line, right? And after this, what you will do is you will say that, okay, after this is done, so I'll call recursively for the I plus 1th word, right? And then what I will do is, like, you will say that what are the remaining number of words left in this case, right? So as I told you, like, if you had these 6 positions left for you and you put CP here, right? If you put CP here, so you have already paid the cost for this thing, right? Now what you're saying is you have these 6 positions, and now what you do is you put let's say you put coder here, right? Or let's say there was a scenario where what you do is you put go here, right? You put go here, and after that, let's say you decide, like, let's say what you do is, instead of this, let's say you had CP here, right? Let's say you had CP here, and after that you don't use these words, right? Because of the constraint. So after this, let's say there were another words as well, right? So what you do is you put coder here, right? You put this thing coder here, and let's say after this, let's say there was another word, let's say CPP here, right? Suppose. So if you put coder here, so how many words are remaining? So if you are in a new line, right? If you are in the new line, so actually the number of spaces that were left were k, right? The number of spaces that were left for you were k, and your current size was what? Your current length was array 5, right? So but actually, is this the case, right? No, because whatever is this. So after this, you have to take this one space, right? And after that only you can start to put, right? So that's why you will take one more space, right? So array of k minus array of 5 minus 1 is what you have to do, right? That is the thing that you have to do for anything, right? For any particular character, right? And in this case, you will say that for this case, definitely the thing will be that if you are using 5 words and this you are taking as a space, so that means that you are out of 6.6 you are doing 0, so the number of remaining will be 0, and in that case you will start definitely from the next line. Okay, that will be the thing, right? Okay, so this is going to be one of the scenarios, right? The another scenario can be that if it happens that you are currently in this kind of a stage, right? If you are at a stage such that the thing is that you have the current word, let's say go, right? And you have the choice to either put CP in this line only, right? Either you can put CP in this line only without paying any cost. You can put CP in this line, and then you can calculate what is the remaining number of words. Or what you can do is you choose not to put CP in this line, and what you do is you move to the next line and then you put the CP word here, right? Similar to this thing. So these are the two choices that you have here as well. So here what you can do is you can have the first choice, right? You can have the first choice and the second choice. So the first choice, let's say the first choice that you choose is that what you do is you move to the next line, right? So let's say you had this thing go here, right? If you had go here, if you had these 6 spaces here with you, and you had this word go, right? So after this, as I told you, the remaining spaces were 3 only, right? But actually are the remaining spaces 3? No, because if you are putting the CP word in the next line, okay, so in that case actually 4 spaces you have left. You will say that the number of remaining spaces were 3, but now since you are not putting the word here, so that means this particular space will also be counted, right? So you will say remaining the cost will be nothing but 4 into 4, right? Instead of 3 into 3, because 3 were the number of left positions. three were the positions where you can put it, right? But if you are not putting any particular word, so that means you are wasting actually 4 spaces, right? That is nothing but remaining plus 1, right? And that is the cost that you have to bear. So 4 into 4 is the cost that you have to bear, right? That is nothing but 16. So remaining into remaining plus 1, remaining plus 1 into remaining plus 1 is the cost that you will have to bear for it, right? That is the thing. So in this case, that is what you will do. So you will say this part, right? So let's try and see this case. So when you will be paying the cost, so if you are paying the cost, right? If you are paying the cost, so the cost will be nothing but remaining plus 1 into remaining plus 1, right? That will be the cost. Let's try and write this in simpler manner. So this will be nothing but remaining plus 1 into remaining plus 1, right? And after that, what you will say is you move to the next index, right? You call it recursive. You call the recursive function for what? You call the recursive function for I plus 1 is what, right? Considering how many number of if you are moving to a new line, right? So if you were go, right? If you put this go here, and after that you had the CP word, right? And you are in the new line, so that means you had initially k spaces were left for you, right? So k minus what? I will write this as nothing but this recursive call will be nothing but k minus rfi minus 1, right? Okay, because you are moving in the next line, so the number of spaces were k for you left, and k minus rfi minus 1 because you were in a new line, right? Otherwise they can be a second chance, right? That you put this cp word in the same line, right? If you put the cp word in the same line, right? If you put the cp thing in the same line, right? So suppose these were the spaces that were left for you, and you put the CP thing in the same line, right? If you put the CP in the same line, in that case you will not pay any extra cost, right? And in this case, what you will say is that you will call for recursively for I plus 1th index, right? And how many number of words are remaining, right? So there would be some initial remaining words that were there, right? After that, this much number of words you are taking, right? That you can accommodate. So that is nothing but remaining number of words. The number of new remaining words will be nothing but remaining minus RFI, that is the number of words that you have chosen, minus 1, right? Because one space you will be leaving, right? And you will be starting to fill the new words from this particular position, right? So that will be the thing, and in this case you will not pay any cost, right? So this is the recursive diagram that will be there. That there will be two scenarios initially, that if it happens that the length of the ith word is greater than the number of words that are remaining, in that case you have to pay this much cost. You have to pay the cost, that is remaining plus 1 into remaining plus 1, and you have to recursively call for the next. We will be putting the next word in the next line, and you have to call for the I plus 1th word, right? If otherwise, if you can put it, so either you put the ith word in the next line. If you put it in the next line, then you will pay the cost, that is remaining plus 1 into remaining plus 1, and then you move to the I plus 1th index, that is the I plus 1th word, with the remaining number of words as k minus rfi minus 1. Otherwise, if you choose to put it in the same line, right? This is nothing but when the next line, okay, I'll write this here. So this is when you are putting the ith word in the next line, considering that you can put it in the next line as well as the same line. So this is when you are putting this ith word in the same line, right? If you are putting in the same line, then you are not paying any extra cost, right? And then you will call recursively for remaining minus rfi minus 1, right? So that will be the thing. Now since this is recursion, right? So notice that since this is recursion, so the overall complexity of this kind of recursive code is always exponential, right? It will be exponential because every time what is happening, there is a function, and in that function they have two choices kind of things, right? Or one choice or two choice. So that's going to be a lot of costly. So what you can observe is, like, if there's a recursive call, right? So in recursion, there's one observation that you can always have. So like what observation you can have? Let's say, if I tell you in terms of, let's say in terms of Fibonacci numbers, right? So what you do is you say that Fibonacci of n is nothing but Fibonacci of n minus 1 and n minus 2, right? So you say this thing, right, recursively, right? So basically, if you will try to do this, so let's say if I want to find the Fibonacci of, let's say 6, right? Sixth Fibonacci number I want to find, so I'll say that's nothing but Fibonacci of 5, right? I'll draw it for you here. So that's nothing but Fibonacci of 5 and Fibonacci of 4, right? And here also you'll say that that's nothing but what, Fibonacci of 4, and this will be what, Fibonacci of 3 kind of thing, right? And this will be what, this will be nothing but Fibonacci of 3, and this will be what, Fibonacci of 2, right? Here, like this, right? And it will go till Fibonacci of what, so this will be what, Fibonacci of 3, and this will be nothing but Fibonacci of 2, right? And here also Fibonacci of 2 and Fibonacci of 3, Fibonacci of, let's say what, 2 and 1, right? So you can see, you can observe some of the things, like let's try and observe. So if you have already calculated this thing, right? If you have already calculated this recursive call for 4, will you calculate it again? No, you will not do this again, right? Because it will be a lot of costly if you are going this much down, and if you are already calculating it. So if already calculated it, so you will not try to calculate it again, right? So similarly the case is here as well, right? So I'll show you through the recursive tree diagram. So here the case is also the same, right? If you have this thing, right? If you have a lot of recursive calls happening, right? And if there are a lot of kind of recursive calls that are happening, so suppose that if you have already calculated this particular recursive call for let's say recursion of I comma let's use the white color. So let's say if you have already called it recursive of I comma what remaining, right? If you have already calculated it here, so let's say if you're also finding it here, right? So if you have not calculated it, so you will say that this particular state is -1 and you'll go down and calculate it. But if you since you are seeing it here as well, so suppose you see this recursive call here as well, recursive of I comma remaining, right? If you see this here as well, so since you have already calculated it here, so you'll not go so much down to calculate it again back, right? And you'll save your time, right? So that's how you're gonna memorize this, right? So this is nothing but recursion plus memoization, right? And that is nothing but the DP solution, okay? And this is nothing but recursive of I comma rim. And if you have calculated it, so you'll not do this, right? So you will have a 2D DP, that 2D kind of DP that will store whether you have calculated a particular state or not, and then you'll return the answer, right? So in this case, if you are going to do this thing, right? So let's try and observe like how we will be implementing this particular code, right? So basically I'll be having a DP, right? And what will be the dimensions of the DP? So I need to have the DP for the indexes as well. Like for first of all, the DP will be for I, and the number of indexes that I can maximum have is 500. So I'll, for the safety, I will say that I can take the DP, right? I can say that I can take the into DP. The first dimension of the DP would be 505, let's say, like, right? I can take it 505, 501, something like that. And the K value, right? The second is what? The number of remaining words. So the number of remaining words in the particular line is nothing but 205, right? 2005, right? This is what I have in this particular part, right? And right, this is what I'll be having. Now what I will do in this particular thing is, what I will be doing is I'll be first of all initializing my DP to -1, right? So I'll say that memset of nothing but DP comma -1 comma size of nothing but DP, right? This is what I will do. And after that, what I will be simply doing is I'll be simply saying that I'll call a recursive function. So return recursion of nothing but what? Recursion of 0. That is, I'll start from the 0th index, right? And initially the number of spaces that I'll be left with K, and I'll also pass the array with it, right? Let's say instead of this nums, let's say I name it as ARR, right? And after that, what I do is in this I have this value as K, right? That is what I have. Okay, I have this int recursion, right? And what I will be having is in the int recursion I'll be having the index I, right? And I'll be also having this thing that is vector int ARR that I have already passed, right? But before that I'll be also having the int remaining. That is, the int remaining will tell me the remaining number of spaces that I have left with me, right? And I'll also be passing the vector ARR that will denote me the number of characters in the ith word, and I'll be also having int ampersand K, right? So these are the things that I'll be having. And what I'll be doing is, if it happens that I reach the end, right? If I have put all the words, right? So if it happens that if let's say suppose that the word GFG was there, right? The word GFG was there with length 2, then the word CP, then the word, let's say, go was there, then the word CP was there, right? So length 2, then let's suppose that the next word was what? Next word was, let's say, coda, right? So in this the length was 5. So in this case, if I have exhausted all the words, right? If I is equal to n, so that means I have placed the last word as well. So in that case, what I will do, if I is equal to nothing but array dot size, right? So in that case, what else they say is that in that case, the cost that I will pay is nothing but 0, right? So I'll return the cost 0, right? That is what I'll return for this particular recursive call. Otherwise, what I'll say is that whether or not I have calculated this particular current recursive state or not. So I'll say that if DP of I and remaining is not equal to -1, right? So that means if it's already calculated, right? If it's already calculated, in that case, I'll simply return nothing but DP of I and remaining, right? That is what I'll do. Otherwise I need to calculate it, right? So I'll say that in the int answer I'll be storing the answer for this particular recursive call. Now there can be two things, right? If it happens that my current RFI, right, if my current RFI is greater than the remaining, right, if it's greater than the remaining number of characters, the remaining spaces, if the current length of my word, if the length of the ith word is greater than the number of remaining spaces that I have in the current line, right, in that case I need to move to the next line. So I'll say that answer is equal to nothing but I'll add the cost. So I'll say that in this case I have to pay the cost, right? So the cost will be nothing but remaining plus 1, because if I, as I told you, why remaining plus 1, as I told you earlier as well, that if let's say I was in a situation like this, if let's say I had put CP word, right, if I had the word CP, and after that what I had was, you give me this much spaces, right? So you'll tell me that the number of remaining spaces is 3, right? Because every time once you place this CP, so you'll call it for the I plus 1th function, and you'll try to put the next word from this particular line, right? That is why you did what you, when you put this recursively here, so you'll say that what you say that remaining minus RFI minus 1, right? Why you do -1? Because you say that okay, this particular space you have to take for the words, right, for the next word, right? That's why. But in this case, if you are not choosing this, right, if you are basically if you are putting the, if you are having the word coder, right? If you are having the word coder, so you have to, you cannot do code and er in the next line, right? You cannot do this, right? So that's why if you are putting this coder in the next line, right? If you are putting the coder in the next line, so that means that actually the remaining you said was 3, but that was when it remaining was 3 when you put the words from here, right? When you start putting the words from this particular position, right? But if you are not putting the words from this particular position, so that means this many places are getting wasted. That is nothing but remaining plus 1 number of positions are empty, right? So that is why you have to pay the cost, that is remaining plus 1 into remaining plus 1, that is 4 into 4, right? Instead of 3 into 3, it will not be 3 into 3, right? You can observe, you will not write 3 into 3, you will write 4 into 4, right? So because if the remaining is 3, so that's nothing, not 3 into 3, it will be, it should be 4 into 4, right? Because 4 spaces are remaining in this part, right? So that is why it will be 4 into 4, right? That is nothing but remaining plus 1 into remaining plus 1, that will be the current cost that you will pay. And then you will say that you move to the next line, right? The moment you move to the next line, so you'll say that you will call the recursive function for I plus 1th character, and what you will say is that what is the number of remaining characters that you have left if you are in a new line. So the number of spaces were k, and how many you have used? K minus arrow 5 minus 1 word. Why? Because you need to have one more space. After that only you can start putting the words, right? As I told you in this case, like if you have this if you just pay this just much cost, right? And after that what you do is you have this 6 spaces, right? That is nothing but k is equal to 6 was there. So let's suppose that you had 1 2 3 4 5 6 spaces. So after that what you do is you have the word coder here, right? You have the word coder here, or let's say instead of this coder, if you had any other word, let's say you had, let's say let's say you had what let's say you had Java, right? If you had Java word, right? If you had Java word, so after this you will you initially had k spaces left, right? After that you have used how many? Array 5 you have used. After that, from where you will start putting, you will start putting the word from this particular space, right? So that is, you can see that the spaces seem to be remaining 2, but actually there's just one space remaining, right? So that's why you will do what? Minus 1. That is nothing but 6 minus 4 minus 1 will give me 1, right? So that's why I'll do k minus array 5 minus 1, right? So that's why I'll pass this thing, and after that what I'll do is I'll pass the array and I'll pass the value k, right? So this is what I'm going to pass in this particular function, right? Otherwise, if I have the choice to either include this ith word in the current line or not, so I'll say that I have to choose the minimum of 2, right? So I will say that I have two choices, right? I have the choice 1, right? I have the choice 1 to include I have the choice 1 to include it in the next line and pay the cost, that is nothing but remaining plus 1, right? Remaining plus 1 into remaining plus 1, I pay this much cost, right? Either I pay this much cost and then I place it in the next line and I call it recursively, right? I place it in the next line, and then in that case if I place it in the next line, so I'll call for the I plus 1th, and that is nothing but k minus array 5 minus 1, because if I'm placing it in the new line, so k spaces initially were there, and the number of spaces that I'll be using, the number of positions that I'll be using will be array 5, and if I want to put a new word, so that is why I'll also do a minus 1 here, right? And then I'll call for array comma k, right? This is something that I'll do. Otherwise I can have the int choice 2 as well. Now what is the second choice that I have here? The second choice that I have here is that I put the word in the same line and I do not pay any cost, and I move simply to the I plus 1th character, right? And in that case the currently the remaining number of lines was something, right? Add some rem number of remaining number of positions, but after in that I have used array of I, right? And minus 1 also for because I always start from the next line, right? Because what is happening is, if suppose that you had this if you could put the word, right? If you could put the word in the same line, right? And suppose that the word was what if the remaining number of words, let's say 3, and you just want to put this particular word is just, let's say it's e, right? So you put it here, right? And the moment you put it here, so you'll take one space from here, right? And because the number of remaining spaces were 3, now what is the number of remaining spaces? Because you will start from here, right? So that is nothing but remaining number of spaces minus array 5, that is the size of the I string, ith word, that is nothing but this, so its size is 1, so 3 minus 1 minus 1 I have to do, because I have to also mark this as empty, right? Because if I'm putting a new word, so I have to put it by taking one space, right? So that's why remaining minus array 5 minus 1 I'll be passing if I'm putting it in the same line, right? Okay, not k minus 1 minus array 5, basically remaining minus array 5 minus 1, right? That is what I'll be doing, and I'll be passing the array comma k, right? That is what I'll be doing. And after this part is done, so I'll simply say that this particular state is calculated, so I'll say that dp of I remaining is equal to nothing but answer. And after this part is done, right, so I'll simply return this particular dp state, so dp of I and recursion I'll return from this part, right? Let's try and quickly see if it's getting compiled or not. So we are having some compilation issues, so it is saying that dp was not declared. Okay, yes, I should be declaring it like this, so I should declare it like this. Let's see if it gets compiled or we have any other issues. So we have some more issues. So we have, in this I was passing recursive, but basically I'll pass what? I'll pass the remaining, right? Why should I pass a function? So that's nothing but in the end I'm returning dp of I and remaining, right? Let's try and see if it gets evaluated now. Currently it's not giving me the optimal answer. All right, so basically I need to check it back again, right? Let's try and see where we might be lagging. So basically if it happens that I reach the end, right? So in that case, if I haven't calculated, right, so I'll return this. Otherwise I'll have the answer, right? And I'll be calculating it, but I'll calculate it in the answer, and I need to do what? I need to store this answer as well. So in this case I had two choices, right? So I'll store the minimum choice, right? So I'll store the minimum of nothing but choice 1 comma choice 2, right? This part I forgot to write. So I'll choose the minimum of the two. I'll initialize my answer. I'll update my answer with the minimum of the two choices, right? Either to put the ith word in the next line and then pay this much cost, or put the ith word in the same line, right? And call the recursive function for the I plus 1th word, right? And I have to update my answer as well, right? So this thing I did not do. Maybe now it should get compiled perfectly. So you can see that we are getting the exact answer on the sample test case. Let's try and submit this problem as well. So you can see that our solution was able to pass all the 125 to 1235 test cases that were there. And talking about the time complexity for this particular problem, so the time complexity for this particular approach is going to be nothing but order of what? You can say it's going to be order of n square, right? It's going to be order of n square, and the space complexity is also going to be order of n square for this particular approach, right? And since I've tried to explain it from scratch, doing the recursive function, then doing the memoization function, so you can write a clear, or you can write what you can, if you have understood this problem clearly, completely. So what you can do is you can write understood in the chat, in the after the videos, you have watched the videos, you can write understood in the comments, right? And make sure to hit the like button if you have understood this completely, right? Thanks a lot for watching this video.